Not wasting much time, we're going to go direct into looking at the cells that make up the liver. So number one, we have the hepatocytes. So what do you need to know about the hepatocytes? Number one, you have to know that these hepatocytes are the primary liver cells that are responsible for so many liver functions that we know. Okay, so about the shape, these cells are large and cuboid in shape, or they can also be polyhedral. Okay, they have a round central nuclei and eosinophilic cytoplasm. So why is the cytoplasm eosinophilic? So if you go to basic histology of cells, you understand that inside the cell there are organelles, and these organelles, based on their characteristics, they can be either basophilic or eosinophilic. So one of the cell organelles that are eosinophilic uh, are the mitochondria. So the mitochondria are therefore responsible for the eosinophilicity of the what of these hepatocytes. So hepatocytes have eosinophilic cytoplasm because they have a lot of mitochondria in their cytoplasm. Okay, so these cells are frequently binucleated. So that means uh, you can see two nuclei in a number of these cells. So these cells also have got what we call apical microvilli. Apical microvilli, okay, for absorption of nutrients. Okay, so these hepatocytes are arranged in uh, what we call hepatic plates. So these hepatic plates are supported by uh, reticulin fibers, or if you want, reticular fibers are the ones that support these hepatic plates. Okay, so between these hepatic plates lie what we call the hepatic sinusoids. These are blood vessels called capillaries. And to be very specific, these capillaries are what we call discontinuous fenestrated capillaries. Okay, discontinuous fenestrated capillaries. So they allow feeding of hepatic space of Disse. So the hepatic space of Disse, this is a space which is found between the hepatocytes themselves, the cells of the liver, the hepatocytes, which are organized in hepatic plates, and the sinusoids. So between the sinusoids, which are the blood vessels, and the hepatocytes, which are the liver cells, there is a space in between them, and this space is what we call the perisinusoidal space of Disse. Okay, this word here, the perisinusoidal space of Disse, or if you want to simply call it space of Disse. So this what is found in this space. What is found in this space? So in this space, you get to find number one, you find the plasma in there. So this plasma is coming from the is plasma. You know, plasma is part of blood. So this plasma, once it leaks out of the hepatic sinusoid, it will go into this space, which you call the perisinusoidal space of Disse. So in this space, this plasma will collect. So apart from this plasma, which has leaked out of the hepatic sinusoid, in this space you also find what you call the ethel cells. The ethel cells, or you, if you want, you can also call them hepatic stellate cells. So these hepatic stellate cells, we'll talk about them later, but just know for now that they are found in what? The hepatic space of perisinusoid space of this, sorry. Okay? Yeah. So that is it. That is it. Okay? So that is about the hepatocytes. That is what you have to know about the hepatocytes. Okay, so we go to the next thing, which are the Kupffer cells. So the Kupffer cells are another type of cells that you get to find in the liver. Okay, so these are macrophages. These are macrophages, and they belong to what we call the mononuclear phagocytic system. Okay, so that simply tells us to say these cells come from what we call the monocytes. So monocytes are blood cells that are in the blood vessels. So once they leave the blood vessels, depending on where they go, they assume a different name. So those monocytes that will migrate to the liver from the blood vessels are what we're going to call now the the Kupffer cells, or if you like, the stellate macrophages. Okay, so location These Kupffer cells in the liver are located in the wall of the what? The sinusoids. So lining the sinusoids. So why are they lining the sinusoids? So the reason here must be very simple. So these macrophages are immune cells. So their function is to scan the blood as it passes, to scan the contents of the blood. Are there any microbes, unwanted organisms, that blood? If there is, they have to sample that one and work on them. Number two, they have to also to monitor the blood cells. If there are any red blood cells that are odd, these macrophages will have to sample it from the that those sinusoids and destroy them. That is their function. So they are in the lining of the sinusoids, and they protrude more into the lumen of the sinusoids. So questions come there. You have to be very, very sure of where you find these cells and why they are there. So that is one thing important about anatomy. You have to know. Once you know where the thing is, ask yourself, why is it there? So that you understand very well. So once you understand, you never forget. Okay? So we're saying these macrophages are located, are part of the lining of the sinusoids. So they recognize and destroy effect or odd red blood cells. So that is why they are in the lining of the sinusoids. Other type of cells is what we call the ethel cells and the or also called sterate hepatocytes, I mean hepatic cells. So I've already highlighted there. So these cells where they are found, you get to find them in the perisinusoidal space of this cell. Okay. So these cells, their function is they have small lipid droplets storing vitamin A and other fat soluble vitamins. So that is the main function. They have these droplets of fats. So in those droplets, we find vitamin A stored in them. So they also store other types of fat soluble vitamins, which you can remember by this mnemonic here, ADEC. So D, E, and K, they will also be found, but the fat soluble vitamin they store is vitamin A. Don't forget here. Okay. So these cells, apart from storing this vitamin A, they're also mesenchymal cells. They're also mesenchymal cells. So mesenchymal cells, these are cells that can actually uh, change depending on what is needed and form other parts or other components of the extracellular matrix. Yeah. So these are mesenchymal cells. So meaning they're regenerative cells. So once the liver is injured, these cells can actually start producing extracellular matrix here for the liver. Okay, so this is very important to understand. In one of these exam questions, I saw a question that was asking about the function of these cells, or rather, it was saying which of the following is true, and one of the options was that uh, these ethel cells are mesenchymal cells. So you have to understand. You have to understand this. Very important. So these cells can also change to myofibroblasts. As I said, these cells can change to anything that is related to the components of the organ in which they are found. Okay, yeah. So they also produce cytokines that help regulate the functions of the Kupffer cells. So cytokines, these are actually communication, the products that are secreted by cells to communicate to neighboring cells. So in this case, it's the ethel cells producing these cytokines, trying to send a message to the Kupffer cells so that the function is regulated. Okay. So the next thing we're going to talk about is the flow of bile and blood. Okay. So this is very, very important here. It's very, very important here. So specifically, we're going first to start with the flow of uh, bile. So bile is produced in the liver by the hepatic cells or the hepatocytes. The hepatocytes, okay? So this bile, once it is produced, it is moving in a direction that is opposite to the flow of blood. So blood flows into the liver from the portotriads to the central vein. So in that case, bile will flow from around the central vein to the portotriad. So this bile flows in spaces which we call the bile canaliculi. So these bile canaliculi are formed by continuous grooves that are found on the apical surfaces of the hepatocytes. So hepatocytes are linked together by what we call junctional complexes. So on top, so since they are linked together in line in plates, in what we have described as plates, so on top they'll be grooved. So Since they are linked together, there will be a continuous groove on top, and that continuous groove will act as a path for bowel to pass, and that groove we are going to call it the bowel canaliculi. So that is how bowel is going to move from the central vein to the portal triad. Okay. So these bowel canaliculi, once they come together, a number of bowel canaliculi come together to form a bigger channel for bowel to pass through, which we call now the bowel canals of Herring. The bowel canals of Herring. So this is a path of bowel. So from the bowel canals of Herring, these bowel canals of Herring are now going to come together again to form now what we are going to call a bowel ductus. The bowel ductus, which we get to find in the portal triad. So we're going to understand the portal triad later when we start looking at the liver lobules. Okay. So one thing I want to make mention of is that these bowel canals are lined by cells we call the cholangiocytes. This term here, the cholangiocytes are the ones that line these bowel canals of Herring. Okay. So yeah, so I've talked about that one. So the other cell which is not mostly talked about is this one here, the oval cells. So the oval cells, their function is that these cells are progenitor cells which produce both hepatocytes and the cholangiocytes. So that is all you have to know about the oval cells. But they may have other functions. So if you're interested, you can go and look up these cells and uh, get more information from there. Okay. So now we're going to talk about now the flow of blood. So it is very, very important to understand how blood moves through the liver. So this is going to give you an idea as a doctor. So for example, a patient comes and you are told this patient has swallowed poison, because you know to say the blood that goes to the liver comes from two sources. So one, we have arterial blood that goes to the liver, we have also venous blood that goes to the liver. 70% of this blood that goes to the liver is the venous blood, which actually comes from the intestines. So whatever you eat after eating, after the digestion has taken place, the nutrients are absorbed. These nutrients, before they can go to another part of the body, they first have to go to the liver, because we know to say one of the functions of the liver is detoxification. Okay, so if this food you have eaten had some poison, so it means that food will first have to go to the liver, then the liver will try to detoxify that poison before these nutrients, which are poisoned, are distributed to any other parts of the body. So in any case, in a case of poisoned food, the first organ that will be actually destroyed by this poison is the liver. Okay, that is very important to understand. So this liver also, the way it is going to die, it will die according to how these nutrients are distributed in the liver. Okay, so let us now look at how blood will flow from the intestines to the liver, so that to understand how this liver will actually start dying from this poison. Okay, yeah. So the first thing we have to know is the main blood vessel that takes blood with nutrients from the intestines is what we call the hepatic portal vein. So the hepatic has to come out. Hepatic part has to come out. The hepatic portal vein. So the hepatic portal vein now will take this blood uh, to the to the liver. So once it reaches the liver, this hepatic portal vein, what would divide? Okay, would divide. So you actually understand in gross anatomy to say this hepatic portal vein comes from the joining of the uh, superior mesenteric vein and the splenic vein, but that is not important for now. So for now, what is important is know that what the blood vessel to carry the nutrient-rich blood from the intestines to the liver is the hepatic portal vein. So this hepatic portal vein at the hilum of the liver, it will divide into the left and right portal veins. So you understand? I said put hepatic portal vein so that you can be able to differentiate the portal veins from the hepatic portal vein. So the portal veins are actually branches of the hepatic portal veins. So it will divide into left and right portal veins. So these left and right portal veins will now reach what we call the portal triad. So the portal triad don't worry, very soon you understand what we mean when we say the portal triad. So at the portal triad, this portal vein will now uh, divide further into what we call now the portal venues. So in the portal triad, you find the three structures. You find the portal venue, the portal duct, the bowel ductule, and the hepatic arteriole. So these three structures, you are going to find them in the portal triad. So in the portal triad, we are saying the portal venue comes from uh, uh, the the portal veins, the left and right portal veins. Okay, so this portal venue now at the portal triad, it will now drain into what we call now the sinusoids, the hepatic sinusoids, the ones we have talked about. Okay, the, the hepatic sinusoids. So one thing you have to take note of here is that uh, at the portal triad, we have the hepatic artery which carries oxygenated blood. Then we have the portal venues which carry deoxygenated blood. So once this blood leaves the hepatic arteriole and the portal veins, and to drain into the portal veins, sorry, to drain into the hepatic sinusoids. So both of these, the hepatic arteriole and the portal venue, they drain into the what? The hepatic sinusoids. So therefore, in the hepatic sinusoids, the arterial blood and the venous blood mix in there. So from there, the blood will move from the portal triad now to the central vein via the hepatic sinusoid. So the hepatic sinusoid will drain into the central vein. The central vein will now take that blood and drain into what we call the hepatic veins. The hepatic veins. So the hepatic veins will take that blood and they drain it into the uh, inferior vena cava. The inferior vena cava will take that blood to the heart. So that is how blood moves through the liver. Okay, then from the heart now, that's how now that blood with nutrients will get supplied to all parts of the body, so that all parts of the body get to enjoy those nutrients. Okay, I hope we are together up to this far. Okay, so that is about bowel and the blood flow. So now let us go to liver lobules and the portal triads. So here I did not put any pictures, but don't worry, I'm going to draw something for you to understand. Okay, so about liver lobules, we have three types of liver lobules. So there's what we call the hepatic astnus, there's what we call the classic liver lobule, then there's what we call the portal lobule. So these three types of liver lobules each performs a specific function. Okay, okay. So each performs a specific function. So we're going to start with the classic liver lobule. So, so okay, uh, okay. So the classic liver lobule will have six parts. Okay, we have six parts. Okay, so okay, so these I'm drawing now. These are what we call the three components that I talked about that are found uh, in the portal triad. So triad simply means three, and you can see the structures I'm putting. There are three here. Okay, there are three here. Okay, so this is what you call the classic hepatic lobule. So it has these uh, six parts and six corners. So at the center of this classic hepatic lobule is this what you call the central vein. So what is important here is to understand now the flow of what? The flow of blood. So this one we're going to name it classic hepatic lobule. Okay, classic hepatic lobule. Okay. Anyway, you know how to write these words. Classic hepatic lobule. So now the thing is, blood will move from here. Blood will move from here. This is a pototriad. Will move via hepatic sinusoid into the central vein. To the central vein. So you've seen. So what is important is the direction of the arrow. You've seen where the arrow is. So the arrow shows the blood is moving from the pototriad to the central vein. So that is how a classic hepatic lobule works. So this is a classic hepatic lobule. We got the next one. So the next one we're going to look at is now this is the hepatic asnas. The hepatic asnas. The hepatic asnas. Okay, the hepatic asnas. Okay, the hepatic asnas. Okay, so very important. After I've put these, don't forget your portal triads now. Don't forget your portal triads. So portal triads feature at every corner of your lobule. So at every corner of your lobule, these portal triads have to feature. Okay. So this concept I'm explaining here is very, very important. It comes in the exam. Okay. Draw the river lobules to explain structure, function, relationship. And what I'm doing here is what you are supposed to do. Okay? What I'm doing here is what you are supposed to do. Okay? So let's go back to this one, the classic river lobule. So this one just shows the flow of blood from the portal tract to the central vein. The one we're looking at now, the classic hepatic lobule. I mean the hepatic asnas. The hepatic asnas, I'm just going to call it HA. Okay. The hepatic asnas. The hepatic asnas, this one is concerned with the movement of nutrients and the oxygen. So this one is divided into what we call zones. It is divided into zones. So it is divided into zones. So remember, what is bringing nutrients and oxygen to here is what? The blood vessels, the sinusoids now, the sinusoids which has now mixed the oxygenated blood and the nutrient-rich blood. So now blood is always moving from the portal tract to the central vein. So from there, blood will move like that. So now this is where the concept now comes in. With this blood is, so that means this thing is will be divided into. So okay, let me just try to write something like that. This area here, see this area, okay, like that. So this area here is our hepatic sign. So it will be into three zones, okay? There'll be the first zone. The first zone will be those cells that are very close. So okay, let me just do this. Okay. Okay. So if we say this is zone 1, zone 2, zone 3. So even this side in this lobule it will be the same. So I have zone 1 here, zone 2 here, then zone 3. Okay. So since blood is moving from here, the portal tract is going to the central vein there. So it means the cells of the liver that are in the first zone are going to receive the most nutrients and the most oxygen, since blood is coming from here going to the central vein. Then the cells in the second zone are going to receive moderate amount of oxygen and the nutrients. Then the cells that are very close to the central vein, these cells in zone 3 are going to receive the least oxygen and nutrients. So therefore, these ones, in terms of when we have a situation where we have oxygen scarcity, so it means these cells here are going to die first, because in the first place they receive less oxygen. So they're going to die first when we have oxygen scarcity. Okay. Then if you have poison, the cells in the first zone here, because they receive they'll be the first cells to receive the poisoned blood or nutrients, they'll die first, these ones, with these ones dying last. In terms of oxygen, these ones, since they receive the first oxygen, these ones would die later than the cells in the third zone. I hope we understand that concept. Okay? I hope we understand that concept. So that is how a hepatic acids works. So it is just concerned with the distribution of oxygen and nutrients to the liver cells. That is the hepatic acids. That is the hepatic acids. Then when you come now to the portal lobule, to the portal lobule, when you come to the portal lobule now, this one, so remember the central vein is always there, and your portal triad, don't forget this. Okay, don't forget this. Okay, so these are two. So these are two. So put these ones your structures here. Put these ones your structures here. Your portal, the structures you get to find in the portal triad. Put them everywhere, at every corner. Okay, at every corner you put them. Okay, so here, don't mind my drawings. What I'm trying to convey here are the principles. So focus only on the principles and you get the principles. Okay. Okay. So here, remember, the portal lobule is the opposite of the classic hepatic lobule. Okay. So the center of the classic hepatic lobule is the central vein. So of the center of okay. So for this one you have to draw three. For this one you have to draw three. At every corner put your triads. Okay. Put your triads. Put your triads at every corner. Okay, the central vein. So here is what is important. So listen and listen very carefully. So I've drawn three liver lobules here to demonstrate a portal lobule. So a portal lobule connects. Okay. So a portal lobule connects three central veins. So after you draw these, you are going to make a triangle that connects the three central veins. Okay. So this triangle I've made here, this triangle is what we call the portal lobule. So the portal lobule, this triangle has to come up out after you draw these three classic hepatic lobules. So you have make a triangle that connects the three central veins. So this triangle now you've made in the center is what we call the portal lobule. So this portal lobule now is concerned with the flow of bowel. So we earlier stated that bowel flows from the central vein to the portal tract. So now what is important now is show the direction of the arrows. So from this central vein, you have bowel moving to the central vein. You put the arrow there. From there, you have bowel moving to the portal triad there. From here, you have bow moving to the portal triad there, like that. So that is how bow moves. So this is connected by a these three central veins are connected by this one. So all of these three central veins are draining their bow into here to the portal triad. So from the portal triad, the bow will now move into the left and right uh, 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 hepatic ducts. From the left and right hepatic ducts, those who join and form the common bowel duct. From the common bowel duct, bowel now make a turn and go to, enter the cystic duct to be stored in the bowel, in the gallbladder. From the gallbladder, if it proceeds now, it will proceed and enter the common the bowel duct. From the common bowel duct to go there and drain at the pancreatic ampulla of vata into the second part of the duodenum, where to get now to digest the nutrients in there. Okay, so this is about the three liver lobules. So don't forget, in summary, the classic hepatic lobule is about the flow of blood from the portal tract to the central vein. The hepatic astnus is about the distribution of nutrients and oxygen to the what? To the liver cells. Then the portal lobule is about the flow of bile from the central vein, the bile to the portal triad here. So the portal triad is the center. Here the central vein is the center. Here still blood, because it's blood that is carrying the oxygen and nutrients. So even if the distribution, so blood is still flowing from the portal triad to the center here. So that is it. That is it. Okay, the class is done. Thank you so much for your attention. Hoping to see you next time.